Today we're going to continue looking at systems of equations, but today we're going to look at what's called a 3D equation. Up until now we've been looking at 2D, something that only has an x and a y. Three-dimensional have x, y, and z, and it is not just one more step, unfortunately, to solve a 3D equation. So we're going to do one of these by hand so that you can see the process. It's a mixture of substitution and elimination. And then we're going to look at how to use a matrix to solve this equation and ultimately wind up putting it in our calculator, which will make our life a lot easier. I do like to do one by hand just so that you can see what the process behind the calculator is. You'll be given three equations. I usually label them 1, 2, and 3, just so I can kind of keep track of what equation I'm taking where. What we're going to want to do is cut this 3D system down to two 2D systems. So we're going to take a pair over to the left and a pair over to the right, not the same pair, and we're going to eliminate the same variable. Now, what variable we eliminate doesn't matter. We're going to just pick the easiest. I'm going to go ahead and pick z because I have an opposite if I pair up 1 and 2 this way, and I have opposite for z's if I pair up 1 and 3, right? So it just can't be the same pair. It doesn't matter what pairs you use, but it can't be 1 and 2 on the left and 1 and 2 on the right. And we're going to eliminate z in both. So I have my first one, x plus 2y minus z equal to 4, and my second, 2x plus y plus z equal to a negative 2. And when I squeeze these guys together using elimination, I'll be left with a 3x plus 3y, z's go, equal to 2. Now when I do my elimination over here on the right with my first equation and my third, I'm also going to eliminate z. Then I'm going to pull these two together and create a 2D system. And I'm going to choose a variable to eliminate. Doesn't look like anybody's easier than anybody else, so let's eliminate x. Top equation is a 3x plus 3y equal to 2. Bottom is a 2x plus 4y equal to 6. And so in order for me to squeeze these together and eliminate the x values, I need their coefficients to be opposites. If I multiply the numerator, the first equation, by a 2 and the bottom equation by a negative 3, then I'll have a 6x and a negative 6x, and so that will work. And so now this will turn into 6x plus 6y equal to 4. And my second will be a negative 6x minus 12y equal to negative 18. And I could have chosen to eliminate y and multiplied one by a 4 and one by a negative 3. I just picked x. Add down, I get negative 6y equal to a negative 14. That's unfortunate. And now I can solve for y. Y, unfortunately, is 14 over 6. All right, so I have one part of my answer. Remember, when you're solving a system, you're going to intersect at a point. In this case, it will also be a point, but it'll be 3 planes intersecting at a point and not 3 lines. And I need x, y, and z now. Well, I got the y. It is a unfortunate 7/3 if I reduce. So now I need to find the other two. I need to take my y value and now work my way back up. So I'm going to pull this 7/3 up to this and say, okay, well, if y is 7/3, then 2x plus 4 times 7/3 is equal to 6. Remember our friend the calculator that does a lot of this for us. I need to say 4 times 7/3 So 4 times 7/3 is that ugly number, 6 minus my last answer, so I'll say second negative sign, so I'll say 6 minus 9.33333, repeating, enter, is that. So now I have 2x equals negative 3.3, repeating, divide by 2, and I want to change that back to a fraction. So I'm going to hit math, enter, enter, and x is negative 5/3. Why do we have all these terrible numbers? All right, one more. I need to find z. Bring the x and the y up. So I have my x and I have my y, and go up one more level. Back up to the top. Pick your favorite. Let's see, who's my favorite? Number 3. So I have an x, which is a negative 5/3, plus 2 times y, so that would be 14/3, plus a z, equal to 2. Let's see, this is going to be a 9/3. Oh, we like 9/3 because that's a 3. And z is a negative 1. And that's where those planes will intersect. It's not terribly hard, but it's long and it's messy. And there's lots of places that things could go wrong, right? So what we could do instead is use a matrix. What a matrix is going to do is take this and create what's called an augmented matrix. It's very important that it's set up so that you got x's on top of x's, y's on top of y's, z's, you have your equal signs strung together, and then your answers off to the right. Now notice that line that I drew through the equal signs. When you're making an augmented matrix on paper, you're going to draw in this line, but you're not going to see it on the calculator. What a matrix will do is pull all of the coefficients, and if you don't see one, then it's a 1 or a negative 1. And we're going to put it in something that kind of looks like a box. And so all my x's will go down there, and I have 1, 2, 1. All my y's will go here, 2, 1, 2. Z's, negative 1, positive 1, positive 1. Now let's say that this one wasn't here, and it just was x plus y. You can have a 0. That's totally fine. Draw the line, and then I'll put my solutions. And this is what's called an augmented matrix. Now the calculator can create an augmented matrix, but what we're going to do is just plug this matrix into our calculator. You measure the size of a matrix, rows by columns. So this is a 3 by 4. I'm going to grab my calculator, and I'm going to click on second x to the negative 1 to pull up the matrix menu. The first thing we need to do is get this matrix in there. So I'm going to go over to Edit, and I'm just going to put him in for A, and I hit Enter. And it says, how big is the matrix? It's a 3, Enter, 4, Enter. And now I'm going to just type this in like I'm typing a sentence. 1, Enter, 2, Enter, negative 1, Enter. It will have to go out to the other side. You know, the screen's only so big. When you hit 4, Enter, it will come back to the next line. 2, Enter, 1, 1, negative 2. And I'm going to type all of this fun stuff in. Oh, made a mistake. 3, 4 is supposed to be a 1. And he's supposed to be a 2. Oh, 1, 2, 1, 2. There we go. All right, so I got everybody in right. I'll check that. And I'm going to hit second mode to go out to the main screen. So now what I want to do is I want to kind of reduce the matrix, if you will. Kind of like you simplify a fraction. We want to simplify this. And what we want it to look like, it's called row reduced echelon form. Row reduced echelon form, RREF. Right? And what that means is that you're going to have 1s on the diagonal, and zeros everywhere else. And then you just have a bunch of numbers out here for your solutions. Now, it's not going to draw in this line. So you have to just know that the square off to the left, see how it's a 3 by 3? That has to be in row reduced echelon form. If it looks like this, then you have your answers over here. So we had solutions that were negative 5/3, 7/3, and -1, I think. So now let's see if our calculator does that for us. In order to do that, I need to go back into the matrix menu, hit second matrix, and go over to math, and I'm going to scroll all the way down till I see R, R, E, F, 2 R's. There's going to be one with 1 R. That's like divide everybody by 2. You know, that's just kind of a simplify. The RREF is a solve. That's what you want. So you hit enter and it pulls it out to the main screen. You have to tell it what matrix to RREF. So I got to go one more time into the matrix menu. Second matrix, and just call him out by his name. See how A is highlighted with the 1? I hit enter, and I hit enter again. I have my row reduced echelon form, so that means these very messy answers off here to the right, that's what I'm looking for. They are in fraction form, but if I hit math, enter, enter, there's our solution. Now, it's imperative that it has the 1s along the diagonal. If it doesn't look like this on the left, these are not your answers on the right. It must have 1s along the diagonal and zeros anywhere else. If you have a situation where it looks maybe like this, all zeros here at the bottom, that's a problem. If I have like 2, 3, 5, no good. Because remember what this says. This says x is equal to 2. Because these are my x's, these are my y's, these are my z's. Y is equal to 3. 1x, right? 1y. This says no z's are equal to 5. 0 cannot equal to 5. This is a false statement. When you get zeros equaling to a number, this is an inconsistent system. AKA no solution. Now, if you have something that looks like this, but instead of having a number in here, you have one more 0 that says 1x is equal to 2, 1y is equal to 3, and 0 is equal to 0. Well, that's true. But that just means any number you pick is going to work. And so even though this is a true statement, it's true all the time for everything. And so this is a dependent system, or an infinite number of solutions. So if you have all zeros, not so much a problem. It's a dependent system, which means one of the planes will overlap. If you have zeros equal to a number, you have no solution. If you have what we had before, then you have one unique solution. It does not have to be a 3D system for you to use a matrix. You can do this for your 2Ds and just use a 2 by 3.